Welcome back to our series in using trigonometric functions here. We looked at cosine, we looked at sine, and we looked at it, they both have very similar properties in the fact that they have a period of 2 pi, they both use the same range of 1 to -1, and they both have amplitude of 1. We're here to look at tan now. So tan is one of those functions which is different to what we already know. Let's go back and recall what we know about tan. So if we do a recall, we know tan is found by doing sine theta over cos theta, which is the same as doing y over x. So if you can't remember that, let's go back to the right angle triangle again. So this here is our theta here, and we have x, y, opposite over adjacent would give me that tan function. So we can see that we can work out tan by using our understanding of these unit circles. Now you'll notice here when we have the tan function, it looks like we've got the same kind of properties. But what we're going to do is we're going to try and work out where the coordinates are for tan itself. It's different in terms of how we looked at the unit circle last time where we could just choose the x values. We now have to do some working out. So let's look at y over x. And let's choose some values here. So we'll have 0, pi on 2, pi, 3 pi on 2, and 2 pi. And what we're trying to work out here is, when we get to those points, what would be the result of when I divide y by x? So at 0, y, which is 0, 0 divided by 1 would give me 0. We come up and we look at pi on 2, y on x again. So 1 divided by 0, well, anything divided by 0 is considered undefined. We then look at the next one here, pi. Well, we've got 0 divided by -1 again. We have 0. We look at 3 pi on 2, -1 divided by 0, undefined. And then the last one we look at would be 2 pi, which is 0 divided by 1, which again is equal to 0. So we can see here that we now can put some information on here. Going from our understandings from our graphing functions before, whenever we have an undefined function, we always do a dotted line. So let's do those first. We've got something undefined at pi on 2. So that means that the line can never touch that graph. We have another one at 3 pi on 2. And that's it. If we have a look at the other information, we've got an x-intercept at 0, an x-intercept at pi, and an x-intercept at 2 pi. Now, I don't know about you, I don't know how this graph's going to look. I know that I could go this way, or I can go this way. I have no idea yet, but what we can do is we can fit in some more information to give us an idea of how the graph will look. So what we'll do is, let's go backwards over this side here. So let's add in some more x, or some more values. So we'll do y over x again. But this time, let's plug in, let's do negative pi on 2, negative pi on 4, and then positive pi on 4. So why did I choose those? Because I know that the negative positive pi on 4 will sit between here, and that will kind of give me an idea of where I'm going to be graphing. Well, if we come back to unit circle, negative pi on 2 is the same as 3 pi on 2, because we're just coming back 90 degrees, which is 1 divided by 0. So therefore, we can say that this here is undefined. Negative pi on 4 is the same as 45 degrees. And we know the coordinates here will be 1 on root 2 and 1 on root 2. However, the y-coordinate is negative here. So if we wanted to work this answer out, we can say, well, 1 on root 2 times 1 on root 2 will give me negative 1. Well, if we want to do that working out, I'll show you again. It'll be 1 on root 2 divided by 1 on root 2 is the same as root 2 on 1. These cancel out. We end up with negative 1. So we get negative 1 here. And the same thing would occur when we're looking at pi on 4 here as well. So this here would be 1 on root 2, 1 on root 2, which then will give me 1 if I do the same working out here. So now I've got some extra information, and this is going to guide me to be able to graph this tangent function. So let's plug in here negative pi on 4 and pi on 4. So we know it's undefined at pi on 2. At negative pi on 4, we're going to get negative 1 and positive 1. So we'll put a mark here and a mark here. So if I sketch this then, I'm going to have a graph that kind of looks like that. So it comes out and it comes up. And this here should be the same in each case. So we can see here, what do we notice when it comes to the tangent function? So what are we noticing? Well, we notice one thing. We notice that it replicates. It goes horizontal asymptote, x-intercept. Horizontal asymptote, x-intercept. Horizontal asymptote, x-intercept. What else do we know? We notice that this here repeats every pi. So the period is equal to pi. We also notice, what about the range? Does it stop? No, it continues. So the range for all y values are all real numbers. So we can say here that we've now noticed the difference between tan and cosine and sine is, well, tan has a period of pi now. It repeats every pi. It has a range where y can be any real number. So we can now look at this and start making changes and alterations. We can go back and look at that formula we did before. A tangent is going to be exactly the same as we did for cosine and sine. It uses the same things. A would change the amplitude, but in this case here, it's not going to make any difference because we can't move, we're not going to be able to change the height it goes because it goes on forever. Okay? B will be talking about how we change the period. So we move the period around, it's going to contract, it's going to expand. C is, well, are we moving this across in the horizontal axis? And D, are we moving, shifting this up or down? So instead of going through 0, we'll go through -1 and continue on. So it's still exactly the same as sine and cosine, except for that A value. What we're going to do in the next video is we're going to look at how we make these changes. We're going to look at transforming a period and then transforming a horizontal change. All right, see you next one.